To Python Epiphanies. My hope for this tutorial is that I see a lot of people going, oh, that's why it does that. Oh, that's how that works. A lot of these aha moments. That's my goal. I've geared this tutorial towards people who have been using Python for a while, so you're not brand new. If you are, you'll still learn lots. Maybe too much. It's dangerous. I don't have this part scripted very well, so let me make sure I say what I want to say. There may be things in Python that still confuse you. I know there were when I was learning Python, about 8 years ago I started. And coming from other languages, dynamic or otherwise, it's like, why isn't this working quite the way I expect? And in teaching Python in a number of venues, I've ran into students who are confused by certain things. And so I've tried to collect that wisdom and put it into here, and I will now pour it into your brain. The format of the tutorial is about 500 one-liners, roughly, most of which, two-thirds of which I'll do, and then I'll let you do a bunch. No, you can't have the handout online yet, because I want you to type it. I want you to actually slow down, type it with your fingers, work on muscle memory, etc. The exercises you will find, the ones that when you're working on them, I have a few easy ones and a little bit harder, and then the last few sometimes are very hard. No one's going to finish. We're going to move on before you're done. That doesn't mean you're slow. It means I've tried to gear it so that the people who are really fast don't finish and sit there twiddling their thumbs, okay? You can go back and finish more of them later. In some cases, I'll go over them afterwards. In other cases, I won't. Let me tell you a little bit about me, and then I want to find out quickly a little bit about you. And I think doing that will make the session run more smoothly. I've been software developer for about 25, 30 years. I have done about half my IT career in software development. About half of that has been in Perl or Python, a couple other smaller dynamic languages, scripting languages, sometimes called. Mostly used Unix and then Linux for a long time, most of my career, until about 5 years ago. I started working for a company that uses Windows, so I've got a Windows machine here with PowerShell. It's not as bad as I thought it might be. But if I get lost, that might be why. What else? Let's find out about you a little bit. So I'd like you to raise your hand if you're using Mac, if you're using Windows, if you're using Linux. Okay, now if you're using Python 2 something, 3 something. Okay, I'd like to find out how much programming you've done in Python. So raise your hand if you've been. Raise your hand if you've programmed in Python. If you've programmed in Python for keep them up, more than a year, more than 2 years, more than 3, more than 4, more than 5, more than 6, more than 10. Okay, that gives me a sense of sort of the curve of who's used Python how much. And I had one other question, I can't remember now. Oh, what languages are you coming from? The big one. How many of you are more comfortable or spent a lot of your formative years of programming or recent years programming in Perl or Ruby, Java, C, C++. Any others you want to throw out there? I'm forgetting the big ones. C#, thank you. Okay, so some of what I'm going to try to do in the first little while especially is geared towards people coming from statically typed compiled languages, so the Java, the C#, the C, etc. Because that's where a lot of people's misconceptions come from. Okay, so I'm going to talk for another few minutes, and then I'll start showing you some stuff. In a statically compiled language, you've got a program, and it has a declaration like int I. And the compiler looks at that, and the reason the compiler has to know the type up front is because it's just working with a byte or a word of memory, and it just needs to know when you say add this to this, it needs to know what you mean by add, right? It needs to know, is it an integer? Because if it is, it's going to compile to a hardware machine instruction, which is add integers. If it's a floating point number, it's going to compile the same representation of data in terms of the bits that are actually in there in memory using a different hardware. So in Python, you don't have to do that up front because Python is an untyped language, right? No, Python is not a statically typed language. Everything in Python has a type. That type is determined when it's created. That type is checked, in a sense, at runtime. So it's not that Python is not typed, it's that it's not typed at compile time. It's typed at runtime, is sort of the way to think about it. So it's a dynamically typed language, is the way I describe it. As part of that, sort of what comes with that is the fact that compiler also has to allocate memory. And so in a typical language, you say, okay, I'm going to declare a variable, I'm going to call it I, it's going to be an int, I need a box to put some content in. That's the way it's often described to people, and the way a lot of people think about it. So I've got this box, and I'm going to put something in this box. And that box always has a name, I. And so I think of that box as I. In Python, that's not the way it works. In Python, I say, give me a 3. And Python goes, oh, a 3, that's an int. Let me go create an int. It does all this big object machinery, creates an int fairly efficiently. And then I say, and assign it to I. And so it takes that int it created out there in memory and gives it a new name, which is I. Okay, so I'm going to try very hard not to use the word variable. I'm going to use the word object and the word name, which references the object. And if you think that way, some of your misconceptions, especially if you're coming from some of those other languages, hopefully will start to dissipate. So I'm going to try to brainwash you and sort of undo some of the damage that was done by getting those misconceptions early on. So let me show you some code and start sort of, the first 10 minutes we'll sort of get the rhythm of how I'm going to show you code and the kinds of ways I'll be talking, et cetera. So I said 500 lines. Fortunately, they're all in here. So I give you a little bit of an overview, and now I'm going to talk to you a little bit about dictionaries and namespaces. An array is a mapping from integers, starting at 0, 1, 2, 3, et cetera, to whatever you want to put in them. Okay? And so here's an example of a little array, of a simple array. I'll call it month number to name because it's mapping from month number to the month name. And I'm going to put those 4 entries in it. The reason I put none in is because I want month 0 to be none and month 1 to be January because it matches it's a good abstraction for the real world where January we think of as month 1, even though we're programmers and we are tempted to think of it as month 0 sometimes. Okay? And then I can reference, I do the mapping, I perform that mapping by saying, okay, take the lookup value 1 and it returns the object. If this is slow, don't worry, it's going to speed up if this seems slow. Okay, and I get back January. So I've mapped from int to anything, right? And I can do the same here. A dictionary maps from anything to anything, not just from ints to anything, from anything to anything, as long as it's hashable. Okay, and so I can do a month name to number, which is like the reverse mapping, and I can go from January to 1 and from February to 2, and it just works. Okay? When you think about names in Python, think about dictionaries, because that's how they're implemented, at least conceptually. There are a few differences and fast locals and stuff, but basically think of this as a dictionary. So let's do this the hard way. I'm going to create a new dictionary called _namespace, and I'm going to look at it, and it has nothing in it. My namespace is empty. I have declared no variable. I almost said declared variables. I have created no names for any objects. I've created no objects and given them names. Okay, so let's add one, a equals 7. Okay, so a equals 7, and now I look at it, and I've got in my namespace a, and it maps to 7. I can change it. Okay, so what I did when I changed it here is I said, create me a new object, stuff it into there, and give it a new key. Create me a new object, and whatever key A might have been in there before, make it reference that new object instead. Okay, simple enough. And I can have, strings and ints and whatever, and I can look at my namespace and it has that stuff. Okay, now I'm going to restart my interpreter to make sure everything's nice and clean. And I'm going to try this using local names instead of a dictionary. I'm going to do it the easy way, which is what Python does. It gives you a dictionary for free, which is your namespace. Okay, so I start by saying, all right, what's the value of A? What does the name A refer to? And Python looks in its dictionary, which is its local namespace, and says, I don't have anything in there. It's a key error, right? It's like looking in a dictionary for a key that doesn't exist. And it gives you a specific kind of key error, which is a name error. It's not defined. Okay? If I look at what dir, one of the ways I can use dir is to say, show me what's in the current namespace. And here I get underscore built-ins. And because of the way I'm doing this, you might get a few differences here in terms of the built-ins. Like my built-ins is different than your built-ins because you're running the interpreter. I'm actually running an interpreter using the interactive module code.interactive, I think. All right, what does this do? Oh, I heard the word assign. That's another one I'm not going to use. It does not assign. I'm not going to look who said it. Okay, here's my brainwashing. Python reads it backwards, like many languages. It sees the 17 and goes, I recognize that. The syntax of the language tells me that's going to be an integer, and its value is 17. So it goes off and creates an integer out in object land. It's an integer 17. It has the contents or the value 17, and it is a type. It's an instance of the integer class, and you can do lots of things with it. Then Python says, oh, there's a assignment operator, and so I'm going to create a new name in the local namespace, which is A. Ta-da, I've done it. Look, I can access A. This is accessing that I'm referencing. I'm saying dereference this, please. Look in the local dictionary for the string A and tell me if it has a value, and it returns the value for me. And then I can look, and sure enough, there's the A that got added to the dictionary. Okay? I can do S equals March, and I get a string instead. Same thing happens, right? Python sees the string, creates the object, adds a new name to the dictionary, to the locals. Okay, 17. So assignment is one of the ways we can modify a namespace. Del, the del operator, is another way we can modify the namespace. It tells Python, please take this thing and get rid of it, drop it from the namespace. So what Python does is it sees this, goes here, gets rid of it, and then what happens? Well, there's a 17 sitting out there in object land, and Python goes, oh, look, no more names referencing that object. I can clean it up with garbage collection. Okay? And you can see it's gone from the names list is there. Not defined. Okay. I can delete S. I'm back to DIRs. Okay. It is going to speed up, trust me. But I want to make sure you think about these are objects that get created, names that reference the objects. Don't talk about variables. Don't even talk about assignment if you can help it, to try to relearn a little bit of how this stuff works. And some of you already understand this, and this isn't going to help you the first 10 or 15 minutes, but for those of you who think about the box and the variable and it's, put stuff in it, I think this will help you. Objects and variables. Yes, there's my reminder that I have a slide to show you. Everything in Python is an object, and it has a single value. A single object can't have two values. It has a single type, some number of attributes, a single ID, which is in CPython. If you ask for the ID, it's actually the memory reference or something like it, but that's not guaranteed to be true. Oh, by the way, when I get excited about something like this, I tend to talk fast, so feel free to tell me to slow down. I'll try to stay slow. It can have one or more names, or possibly zero, in one or more namespaces. Okay? Right now, I'm just talking about the local namespace and saying it's got a name. Well, you can have more than one. And it usually has some indirect base classes, or direct base classes. Hang on here. Let's go back and... So, I'm going to show you some examples of types. I created an int. So it created an object when I did that. Did it have a... So that int had a value, it had a type, number of attributes, single ID. Okay, let's look at these things. So here, let's create the objects. Here's an int, there's a float, there's a string, there's a tuple, and there's a list. Okay, they have a type. What's the type of one? It's an int. Floats, it's a string, it's a tuple. Of course, I need the parentheses doubled so it doesn't think I'm passing it 3 parameters, which does something else you'll learn later, if you don't know already. And it's a type list. It has some number of attributes. If you pass dir an argument, then it will actually check the attributes of the object that you're passing to it. Whew, it's got lots. Has all these underscore, ABS, underscore, for example, which we colloquially say dunder abs, or dunder ABS, for double underscore. And then it's got a few that have real names. You already know that double underscores means it's sort of hidden or behind the scenes. Let's look at some of these attributes. And here again, I have to use parentheses to make sure so it doesn't think I'm entering a floating point number. All right. So the int1, it's an instance of a class. It's an object, and it's got a docstring, which is the docstring for the for the object. Does it mean that there's actually a docstring hung off that object? Probably not. It's probably hung off the class. In most cases, it would be hung off the class. In this case, it is. And it's got, so what is its class? Type int, right? So one of the attributes of the int object of I think all objects is that there's a dunder class attribute, which is a reference to its type. Let me take a time out here and tell you something I forgot to tell you beforehand, which is 99% of what I'm telling you today at the conceptual level is accurate. There might be a few things that are a little bit weird. 95% it probably is accurate if you start to actually look at how I'm telling you the exact answers. I've figured this stuff out over the years by playing with Python. I haven't gone to read the C that's behind Python. I could, but it hasn't been my priority. And I've got two great TAs here, Dan Lucier and back, who was actually at my dry run of this a month or so ago, and Jean-Paul Calderon, who both of them know lots of Python. And if they or if any of you find problems, like you're like, wait, Stuart, that's not quite true, tell me. I'd rather hear it now and make sure everyone's got the right answer than me lead you astray, right? So almost all this is right, but I bet there's still a few things where I'm confused. And I'd like to hear it now, so we all can. But I'm not going to do the Donald Knuth thing and offer you $2 and $4 and $8 if you find them. Okay, back to where we were. So, has a class. Here's some other attribute. Here's the class attribute of a floating point number, the class attribute of a string. Here's another example of an attribute. What will happen if I do this, if I evaluate this? It's just going to access that attribute, and because I'm in the read eval print loop of Python, it's just going to show me what it is with some kind of representation. It's the built-in method count of the string object, okay? And that is which object it is. So there's an attribute, which is a method. You can call a method, of course. You can access an attribute and then do something with it, like give it parentheses and call it and look for S's. Here's another attribute, this time of a tuple, another attribute. And then they have IDs. Every object has an ID, remember? A type, a value, a type, a number of attributes, an ID, and some names, and some base classes. So IDs, there are some IDs, whip-de-doo. Let me grab the inspect module and use the get MRO, get method resolution order method of, or function of the inspect module, and say what is the type of hello, or what's its MRO for it, and you can see that the string hello is of type string. It has a superclass base string, and it has a superclass object. Okay. Hello type get MRO. Let's do it a different way. Hello. So the type of hello is means they are the same, not just that they're equal, but they are the same object, basically. So the type hello, when you call type on the string hello, it returns an object. And that object has an ID. And if its ID is the same as the object that's referenced by the class attribute of this string, then is will return true. And I can just chain them together and see that actually all of those are actually the same thing. So when I say type hello, it's the same as str, which is a built-in. It's the same as hello's class. And hung off of the class object, it has its own set of attributes, including bases, right? And it's got a base type string. It's a tuple because this is multiply inheritance. Python, you could have multiple superclasses. So we'll grab the first one, and we'll grab its bases, and you can see string, base string, object is what we get. So it's all wired together behind the scenes with these dunder attributes. Okay, so now what I will do is stop talking and give you a chance to, where are we? All the way down on page 3, to take a few minutes and go through these exercises. Some of the things in these exercises are just straightforward reinforcing what you've seen. There'll be a few things where you might learn something or you might just get frustrated. I'll go through it quickly to make sure you learned it. And occasionally you'll see there might even be errors on there that are in there that are on purpose. And then me and the other TAs will wander around and help you if you get stuck. To make sure you know what's going on and we can learn together to see what you're learning. So you did a dir and you saw some built-ins. What's in here is interesting. Type ID j equals 1. Oh, when you did j equals 1, did you notice that ID of j and ID of I are the same? Why would that be? Why? What's that? There only needs to be. That's why. One of the mistakes I made in a tutorial I was given, like one of my mental misconceptions myself, is that I was thinking, well, there's only one because ints are always there. I said, well, no, ints aren't always there. And someone in the tutorial said, no, Stuart. I'm like, oh, right. That was, I had this huge gap. They aren't always there. They get created when you need them, but no need to create more than one. And the reason you can do that is because ints are immutable. They don't get changed. And so I think this is the last time you'll see ID equals equals. We'll just use is, which is the short version of the same meaning. Anything else in here? Here you got two names for the same object, right? They are the same, and if you change one, well, you changed it, right? This isn't if you change one, you change the other. No, they are the same object. These are two names for the same object, right? These aren't two variables. These are one object. It has two names. That's the way I'd like you to think about it. You might get tired of me being the, don't use a variable, but I think you might thank me later. Thank me later. Yeah, so this one is sort of a setup, foreshadowing for something later that I'm going to show you and explain what's going on. This m and m plus equals. Some of you know not enough to think this is odd, and some of you know enough to know why it's not odd, and some of you right in the middle, you might go, well, that might be odd, and I'll show you why it's odd or not odd in 20 minutes maybe. And somebody asked me, what's a slot wrapper? And I said, I don't know. I know what a slot is, and I explained it briefly. I don't actually know exactly what a slot wrapper is. I can, based on my experience of seeing other wrappers in Python, I have a sense for what it does. It wraps a slot or pretends to be a slot or something like that, but I don't actually know what it is. I don't have a good answer for that one. Okay, so int div and int true div. These are, the dunder div is regular Python 2 division. I think I have that backwards. Whereas true div is, now which one's integer? Actually, I don't remember which is which by name. Anybody know? Which one's integer division, which one's the double slash? One of them's each. You can look it up. I don't remember right now because I never use the dunder ones. Yes, that's when I tried to make all this work in 2 and 3. I actually forgot to test some of these in this one, so thank you for pointing that out. And that's because in Python 3, you no longer have to do from future import division is one way to answer the question. And here, if I try to do an assignment, you can't change attributes of a built-in type, okay? So something you just might have learned. Is doing what? Sorry?
I think what the slot wrapper is doing is providing exactly that concept.
So what the slot wrapper is doing is providing exactly this error? Okay. Okay. Maybe I'll get the answer from one of our local experts who in many areas know more than me about Python, and then I can tell you. So a few other interesting things. Okay. Oh, and this one, if you call object with no parameters, you get just a random new object, which sometimes people use as a sentinel value for things. If you need some value that is completely different than any other one, but you can get it that way. Okay. I'm going to talk for a while again. Sorry about that glitch. I didn't fix that way. I'm going to talk for 4 slides. So I've hinted at namespaces. Let me give them a little bit more rigorous treatment. Namespace is a mapping from names to object. Think of it as a dictionary. Assignment is a namespace operation, not an operation on variables or objects. Right? That's almost 100% true. When you say A equals 7 or M equals a list and N equals M, you're not doing anything, almost, to the objects. It's an operation on the namespace. Now, the way in which I'm lying is when you assign a name, when you create a new name in a namespace to refer to an object which exists or doesn't exist in either case, there is a counter that says how many names does this object have, because that's when Python knows to garbage collect. But that's an implementation detail in a way. Okay? So remember, assignment is changing the namespace. A scope is a section of Python code where a namespace is directly accessible. Okay? We haven't seen scopes really, or talked about scopes. Directly accessible namespaces, you access it just by typing its name, which I show you. So way back at the beginning, I said, A equals 7, enter, and I type A, enter. Well, that's how you access it. You don't have to do this monkey business I did. For an indirectly accessible namespace, you use dot notation, right? So if you do if you type that in the Python interpreter, you know what it'll do. Or you can have, they can be chained in a sense, right? So sys.version. So again, the way Python reads this says, grab me this. This is a name in the namespace. Give me the object that it refers to. Now take that object and try to access its version attribute. And if it succeeds, it gets back the object. Take that object that came back, access its major, an attribute named major in that object. So it's going through these objects looking for attributes. Here is the direct namespace search order, quoted almost directly from the Python tutorial. Innermost scope contains no local names. So if you have a function, for example, you define a function. Inside that function, use a name that's new, and make an assignment to it, then it's going to create a new name in the local namespace. And you exit the function, the name goes away. That would be an example. If it can't find it, if you try to use a name in, for example, a function, and it can't find it as a local in the function, it'll go looking up the chain, right? It'll look into the enclosing scopes. Then you've got the current module's global names and the namespace containing built-in names. Okay? So you've seen built-in names. We'll look at this in a bit. Namespace changes. I've told you about assignment. I showed you del. Import is another. Def is another. And class is another. I believe those are the only ways you can change a namespace commonly. There's one other I'll show you. Okay? And they all happen in whatever the local scope is. Okay? So whenever, if you're defining a function, and in that function you're defining a function, well, that second function definition inside the first is going to change the namespace of that first function that it's inside. Yes?
If you create a local variable, a local object pointing to an indirect namespace function, will you get a performance improvement, for example, if that's inside a loop? So you don't have to look it up in a dictionary?
If you create a local namespace,
If you create a
local object
pointing to an indirect namespace,
pointing to an indirect namespace,
like a function,
like a function,
inside of a loop, will you get a performance improvement inside that loop? Because
And
you don't have to look up in the dictionary every time?
and you do, and will you get a performance improvement in that loop? The reason I'm repeating you is for the video. I don't know. That's not an interesting question. I'm curious now, but I'm going to not answer because that's not the focus of the tutorial. But great question. I don't mean to dampen. I like questions. Give me lots. I just won't answer them all. Sorry. So namespaces. If a name is declared global, let's not tell you that yet. Let me show you this part. Here's some weird behavior having to do with globals and locals. Okay, let's create an object. I'm going to go slow still. I'm still going slow, brainwashing you. If I create a new object, which is an int 1, and assign it the name x in the local namespace, and then I define a function, test1, and I say, show me what x is. Okay, if I call it, it can see it, right? There is no local x in here, so it goes out and grabs the other one. If I create test2, new function, it assigns x equals 2 and prints the value of x. And then let's check to see what x is before I call test2. Let me call test2. You see that x is now equal to 2. Oh, I just lied. I said x is now equal to 2. That's not quite, I'm confusing you. But x is still 1. What's going on here? Well, here, and I apologize for that blank space. I thought I fixed that. That'll show up lots today unless I go fix it during the break. The x here, I'm creating a new local variable, a new local name in the function test2, and I assign it a value, and it shows me the value is 2, and then when I exit the function, I'm back to the local namespace, in this case global because I'm at the interactive prompt, and you see that now when I access x, I'm not getting that one because that one's gone. I'm getting the global, the one at the higher scope, the outermost scope. Okay? X is 1. Be ready to be surprised. What? What's going on here? Anyone seen this and wondered what's going on? Oh, sorry, I'm not going to. Thought maybe I'll be like, oh, please tell us, Stuart. Right, so it tells you what's going on. Local variable x referenced before assignment. So that tells us there is a local variable in this function, and its name is x. Why is there a local variable? Because when Python went to compile this function, it saw an assignment and said, oh, they're creating a new local variable. I can't believe these. They're creating a new name in the local namespace for this new object, right? And then when it went to run the function, it tried to access that before it had a value, before it existed in the namespace, right? So that's one of those weird things that you might see where Python does two passes, right? It compiles the code into bytecode and then executes that bytecode, right? And of course, x hasn't changed. Right, of course, x hasn't changed because it never even finished executing the function.
I'm confused on that example. Wouldn't x already be defined globally in that case?
It was, but Python looks in the local namespace first. And the local namespace for this function, the def is gone up there, but it's def and then the print and the x. And absolutely normal that you're confused. This is a confusing thing. Hang on. So when it sees this x, it looks in the local namespace. When it compiled the function, it knew that there was it found that there was an x local, and so there is a local x. You had a question?
Are you saying that assignments are special in that way? Are there any other statements that would create a name like that?
I think any of the earlier, the list of things that can change a local namespace would probably, I think all of those might apply. All of those that you can do legally in Python.
Sorry, to go back to that example.
Sure.
If you didn't have that x equals 3 in that function, would it pass then? Because you had it defined globally? No, it would not. Test 1.
Right. That's why I'm going back. Test 1 did the same thing. And it works.
Okay.
Yeah.
So one quick question about test 1. When it runs, it scans its local namespace for x. If it can't find x, then it goes to the parent namespace or the global namespace. How does it know where to look for x if it doesn't have it locally?
Where'd it go? These rules. Right? Okay. Here's that weird error again. Okay, now let's poke around a little bit and see what I'm talking about. And I think I just have a couple lines here to show you that. Let's make sure I know where I'm going. Yeah, it's just this test 1 had no local variables. Test 3 does have one, right? And this is some information hung off of the code, the compiled code of test 1, and it's got actually some code attributes in there. And one of them is the variable names. That's a tuple of local variables. Is the names of local variables is what that covar names is defined to be. Okay? Yes?
So even though it returned an error, it's still keeping track of that x was in there?
It tracked that when it compiled the function. The function has been compiled.
It's not getting rid of it? Even though it's
So compilation of the function into bytecode is completely separate from calling the function and executing the bytecode. Right? We think of Python as an interpreted language, and that's sort of true. It compiles and then interprets, compiles and then interprets, right? Compiles once, interprets lots of times maybe. Well, executes really the bytecode, right? So that's why it's always there. So it can't see, in theory, it could see the error and then go back and invalidate the code or something, but it's too much work. Yes?
If you hadn't called test 3 yet,
Yes.
that would still be.
That's correct. This exists, good point. This existed once the definition of the function was done. It wasn't created during the interpretation of the bytecode or the running of the bytecode. Okay? So I know you're not all quite totally satisfied. I'm leaning towards moving on though. Yeah?
Why did you catch in the compilation error? Like, it sees that x is used, but it sees that x is not assigned. Why is it not compilation error?
Don't know. Not sure.
It can't quite tell in all cases. You have a for loop, for example, that assigns a local, and it doesn't know if the body of the for loop will actually execute at compile time as it might still run time.
Right. So it can't know in all cases because there are cases where you might have legitimate code that wouldn't have that error depending on conditional execution. Would be another example. The for loop example, conditional execution, etc. So here's Here's the, from the Python tutorial, it'll actually tell you what's going on. An attempt to write such a variable, simply blah, blah, blah. Right, so it sort of hints at here's what's going on. Okay? So again, I'm not gonna, I want, this is sort of to help you understand some of the stuff that's going on behind the scenes, that if you know about it, then when you run across it, you go, oh yeah, there's a reasonable explanation, as opposed to, wow, I thought I understood this language and I'm all confused again. So I'm trying to get you past that confused and frustrated to, oh, okay, there's a reason for this. And I think it's now your turn. Oh, what's this? I forgot, there's another line, next page, I think it is. All right, now if I want to, pardon me for a moment. Are you missing that? Am I missing that? Where is it? I'm lost. Oh, I just went too far. Thank you. I skipped ahead a little bit. So bottom of page 5, there's this. Right, so here, if I say global X, this is what global does, is global says break the rules. Don't look in the local namespace first. For this name, I want you to go outside and look for it. And so it says, okay, then this will work the way it would have worked anyway if it were the only line in the code. This, the behavior here changes. So this changed 2 behaviors relative to the previous function. One is the assignment is going to assign to the name that's global instead of the one that was created that was local. And this is going to make it not create a local. And because it didn't create a local, it's not going to have the same error. Right? And so now we have x equals 1, we run test 4, before it's 1, after it's 4, and at the global level it's 4. Right? So there's a case, there's an example of where you might use global when you're doing some really complex piece of code like these 3 lines. Okay, and there's the test 4, see, no locals. Okay, and then I showed you this slide already, and it's your turn. No, it's not, it's my turn. This is one of those sections where I don't give you a turn to talk yet, or to play yet. I'm going to keep going and then give you some exercises. Any other questions before we move on? Again, if you don't completely understand this, you want to ask me after, I'm happy to go do it, but let's keep going. I don't want to focus too much on this weirdness. Okay, so I'm going to restart again and just look at a couple things about the local namespace. So if I say, what does help do? It says, call without an argument returns the names in the current scope, some of the attributes, or attributes reachable from it. So just notice that dir isn't just showing you the attributes, it's showing you some of them, and it's showing you ones it might be getting from somewhere else. Okay? So here's my local dirs. What's the current scope? Anyone know? I mentioned it already, it's global. This is the global scope at the read eval print loop, the interactive prompt. That's important. Inspect. I'm going to grab preview. I'm just setting this up so I can actually show you some stuff. Huh. If you do that, this scrolled for a long ways. I want to see all the stuff in built-ins, and it just got lost. So I just want to show you what the built-ins are. And to do it, yeah, see, it's a mess. Hang on here. Just hang on here. Lots of keys. Let me just show you. Now, I almost took this part out, and I should have, but I have to have it there if I actually want to show you what I'm trying to show you, which is, now you can see half the built-ins that I can see, which is maybe, I think it's almost an identical list to what you see, but slightly different maybe because of the way I'm running this. So most of the built-ins that you can get at the global scope are, remember that was the 4th place it looks, are errors and warnings. There are kinds of exceptions. And here are all the rest. A few other exceptions and warnings that don't have the word warning or error in them. And then there's all these things. So this is all the stuff you get built into language before you've imported any library, before you define any function yourself. All of these are built-in names. Okay? And PEP 8, Python Style Guide, I think speaks to this. You should avoid using these names. You can override most of them. You can create your own names that use most of these. In general, it's a bad idea because it will confuse your readers. Okay? So I just wanted to show you that's what your built-ins are, and now you get a chance to play for a few minutes. Okay? And feel free, especially during the breaks, to raise your hand and get one of us to answer questions about the stuff that I just covered or whatever you're working on. Okay, let's move on. So local namespace. Let me get to the right page. So one of the things that I should let you know is that I mentioned, I can't remember if I mentioned or not, so in the global namespace, sorry, at the interactive interpreter prompt is what I mean, when you call the locals function, it returns you a reference to the dictionary, which is the locals, or this thing that's a lot like a dictionary, which contains the local names. And when you call the globals function, it returns a reference to the same thing, which is, and both of these are the global namespace, correct me if I get the language wrong, it's the implementation of the global namespace. If you were in a function, and I actually had an example in here that shows you how, if you try to, well, let me go a little further here. So this works here. If you do this inside a function, you can make this break. It won't work. And the reason it breaks is because the local namespace, here, locals and globals both return the global namespace implementation. If you're in a function, you can call globals and locals, and they return two different things, one which is the globals, and one which is actually the locals of the function. And the locals in a function is a different implementation of a namespace for performance reasons. It uses something called fast locals. And you can actually, I think it's exactly this code. You try it inside a little simple function, and it'll break. You'll get unexpected behavior, and that's why. All right, so at the conceptual level, always think about namespace assignment in any namespace as a dictionary. At the implementation level, there are some optimizations that make that not quite true. That's the short answer. Oops, I just fixed that last night, so I wouldn't have to type those. But it's okay, I could just tell you what they were. I didn't test that piece. All I wanted to show you is you can try those two statements if you want, just to get a little bit more, what are these things in terms of how are these things actually implemented? How is true implemented in Python? Well, you can get some clue about it looking at things like this. So let's look at namespace changes. I told you that namespace changes, I mentioned these, and we're going to go, the outline for the rest of the course I sort of going to go through in roughly this order. But with lots and lots of depth. So you might forget that we're even on this map. But we've talked a little bit about assignment. I mentioned del. I mentioned this briefly. And this one is just, you'll hardly ever use that. But it's good to be aware of it. The three that we haven't talked about very much yet are import, def, and class. The three other ways to modify a namespace. Okay? So I restarted my namespace again, so I get a nice, clean, uncluttered namespace. Let's look at import. If I do an import of pprint, what that does is creates a new name in my current namespace, and what it refers to is the module, the prettyprint module that I just imported from the standard library. Okay, I can access that new name, and it tells me it's a module. That's what kind of object this refers to. I can look at its attributes, and it's got a bunch of dunder ones, and then it's got is readable, is recursive, pformat, pprint, safe repr, and warnings. Pprint's the one that I use a lot, the one I'm familiar with. And let's look at here the ones that are just the ones that aren't hidden, or the ones that aren't dunder. If I access, here's where I'm doing attribute access, and so this is going to say, give me back, again, I'm going to slow down so you think about it this way. This says, give me back, what does this name refer to? It refers to a module. Please look up that attribute on that module, and what I get back is the pformat function inside the pprint module, which is accessible to me through this dotted notation in my local namespace. Okay? And there's another one. Shows me these are these functions. And the name function, the pformat name here and the pprint name here, those are the names that actually, that's what showed up in the def statement. When a def statement is executed, is evaluated in Python, the name right there gets stored in the object so you can display it here. You can actually change that if you need to. There are a few cases where you might want to. Okay, so you notice here, if I just type foo earlier, I should have done that maybe, I get name error, foo is not defined. If I type pprint foo, I get attribute error, module, object has no attribute. So you see the differences in terms of where it's going to look for the name. One's in the local namespace, one's saying, well, go look in that object's namespace in a sense. Okay. What this does is modifies the local namespace in a slightly different way, and if you probably know how to read this, I'm going to import I'm going to go look for that module, import that name from that module, and this is one of the confusing modules, which has a module and inside of the function with the same name, but I want to call it something else, and so I get this thing, right? I get, now I've got pprint and pprint function, right? Right, so pprint's the module, pprint is the function in the module, pprint function is the new name I just gave it, and I've got, these are two names for the same object, which is a function pulled out of the standard library, right? And there's information about the module, pformat function, I can get rid of it. I can import pprint as pprint module. You can do all sorts of funky things with names here, right? Pprint module, pprint. Fairly straightforward stuff. I don't think I have a lot more of it. I do want to show you that these imports, you may never have thought about this, but they're kind of funny in that you're doing an import, but you're not passing it a string. You're passing it a name that doesn't exist yet. So why doesn't Python see this preprint the first time you do an import? Say, I don't know what that name refers to. It's because the import statement does something special to make it easy to read. If you need, sometimes you might need that to be a string, so you can refer to it, for example, as an object. And so you can do this, and there's all sorts of stuff you can do, right? So here what I've done, this is a little confusing, but I've said, make this module name a name which refers to a string. Take that string, pass it off to the import function, the dunder import function, and then whatever you get back, make this the local name, right? And so now the name in my local namespace is string module, because that's the name I just gave it. And what it refers to is that module. Okay, and I can access an attribute there. Of course, import strings is usually the way we would do it instead of this, all this stuff. Okay, now let's do, look just very briefly at an import. So I have on my, in my directory here, I've got a folder called folder1. There's a file called file1.py. I've got a folder called module1. It has the same file1, but it also has a dunder init.py, underscore underscore init underscore underscore .py, which is just an empty file. There's nothing in it. It's 0 length. Okay, so reset, make sure it's clean. Okay, if I say import and give it the name of a folder, even if it has Python files in it, I can't do an import on it. I can't even do that kind of import on it. If, on the other hand, I try the same thing, I've taken this and just added an empty init.py file, and I do an import module1, it works. All right? It's got a bunch of stuff in it. And if it's got that init, I can do that kind of import as well. And it's got that attribute, which is the namespace that got in from that file, right? And it's got, in there, it's got a particular attribute that I threw in there just so you could see it. Okay, so okay, here I could do from module1 import file1 is the other way to do it, and then file1 shows up in my local namespace, and it has the same attribute, so two ways to get at it. Okay, in terms of import, read PEP 8 if you haven't. So we're not going to go into depth about all the ways you can do import, all the ways that init can work, what init can do in terms of importing other things and sort of presenting a particular interface. Just wanted to give you a brief overview of import, one of the ways you change the local namespace. Okay, and now it's your turn to go play. Couple questions. Somebody asked, what's the difference between a module and a package? And I couldn't answer very well, but now I can. Any Python file that you load is a module. If you have a folder which has an init.py, a double underscore init.py file in it, that folder and its contents, or the parts of the contents referenced or pulled in by the PY, the whole thing is is a package. So that's the difference between a package and a module. And as Jean Paul pointed out in his answer, thank you very much, it's not just init.py. There may be some other ways of getting it turned into a package, other kinds of init files like SO files. And the other question that stumped us is there any way to do a reload that has this on something that's been from A import B and get that to be reloaded? And I'm not aware of an answer. There isn't. Cool. This is great having you here. Okay, let's go on to the functions. Any other questions before we move on? Okay, and there was one other question, which is, what's the teaching objective on this second dir? Great question. There's not always one. I'm just like, well, just look at them again. So, but it is a good question because it makes me think, oh yeah, is that really helpful? I mean, I have put a lot of effort into trying to actually, like I'm not just throwing these things out. I spend a lot of hours making sure, okay, now they're going to be in this frame of mind, let's put this, that will lead in this direction. It doesn't always work, and even when it does work, it's not going to work the same for everyone. Anyway, functions. Oh, let's fly through here. Let's really fly through here. So functions are another way that you can change a namespace. Okay, I'm going to restart again. Whew, there's a big complicated function. All I'm going to show you here is just a brief review, probably for most of you, of how keyword arguments work. So I've got a function, takes two regular or unnamed arguments. It takes two keyword arguments with default values. It then takes, sorry for the gap, it then takes any other number of non-keyword arguments and any other number of keyword arguments. And that's what the star and the double star on the receiving end at a function definition do, will collect multiple arguments, right? And then I just print them out because I want to see what they show. Okay, so now I've defined this function. What do you suppose its name is? Right, because that's what I called it, right? And I can see that f is now in my local namespace. I can muck with f's name if I want, right? And there is a valid reason why you might want to. If you're having a function that creates another function or closure or a couple other cases, you want the function that comes back to be meaningful to the user in the context they're using it in, not in the context that you wrote it in, right? And when I say context, I mean conceptual context, not the scope. What's that?
Hide the implementation.
Exactly, hide the implementation details. Thank you. So, what happened here, though? I thought I just changed its name. I changed the name attribute of the object, which the local name in my local namespace refers to, right? But I didn't change the name, right? So f is still the function. It's just that its name. F is still the name of the function in the local namespace, but if you ask it what its name is, it says its name is .g, right? Just hammering in the namespace thing, what's going on here. And there's the function. And you can see that when I change the name, here's where it shows up, making a more helpful error message in a case where I've hidden implementation details. In this case, not. It's confusing. Func_dict is empty. Not anymore. All right. This, if you haven't seen this, it might be a little surprising. You can have add arbitrary attributes to functions. They are used by some libraries. I don't think they're used by anything other than some library uses them because they're convenient. I'm not aware of any other use. Func defaults. There's a whole bunch of stuff. I'm not going to show you everything, but there's a bunch of stuff. You go look at the dir of f. There's all sorts of attributes. We saw earlier, one of them is called func code. You can look at all its attributes. So there's lots of stuff you can poke around in behind a function if you want. I'm going to stop there and just show you a couple of these, right? So we call f1, f2. These are defaulted. I can give them the names if I want. I have, right, arg1. It's different here. Oh, I can change the names. Thank you. I can flip them. All right. So here I've got an extra arg1, arg2. Oh, because, right, so you see the 3 goes in the keyword arg3, and this one still defaults to what it was. All right. This one defaulted, this one I got overridden. Like all these things, right? And it gives you errors in some cases. So we're not going to explore all this, just so you're aware that there's this complexity. If you're doing lots of weird things with combinations of keyword arguments and non-keyword arguments and star and double star, there are a few restrictions, some of which I think were relaxed in 2.7 or 3. One of these is slightly different, and you can give them all. Okay? So now, your turn, I think, very soon. Anything else of interest here? Right? These are just, you can see these extra arguments are getting passed into args. And these extra arguments are getting passed in, right? So here, 1, 2, 3, 4. Well, the 3 and the 4 filled up the keywords. Then the 5 and the 6 filled up the non-keywords, and the 7 and the 8 went into the other keywords. So all of these are the arguments that it received. And again, if you want to know more about this, start by reading this code and figure it out, or go look up the documentation. So now it's your turn. A quick turnaround for you to play, and we've got about 15 minutes till the break, so we'll probably get through one more section. All right, let's move on to the next section. About the only thing the one thing you noticed is the star and double star on the sending side. You may not have been familiar with, some of you. Most of you probably are. Lists are mutable, strings are not. This is a section where last time I did this in my dry run, made a few mistakes and had to dig a little deeper and get the right answer. I hope I get it right this time, but and it's a little bit tricky, but I think I think it'll help you understand a few things if you could follow. So I'm going to say let's create two names at the same time. By the way, which is kind of interesting. You could do this in Python. Let's say old s refers to the same object that s refers to, which is the same object, which is the string hello, right? So let's create that thing, and then. This is kind of complicated, but it doesn't change for the next whole section. So let's see what it is. I'm saying show me the old one and the new one, or the same one in this case. Are they the same object? And show me their IDs, just because then you can see, yeah, they're the same ID. That's why the is true. So old s and s they are two names for the same string. What does that do? Well, the simple answer is this. We say here's how Python reads this, and this is the simple answer, and it's a lie. Evaluate this s. It's a name, right? Look it up. Oh, I get the object which is the string hello. Take hello and there and concatenate them together, and then take that resulting string and make s change what s referred to so that it now refers to that new string I just created. Okay? I'm looking to the experts in the corners to make sure I haven't lied yet by saying it was a lie even. Okay, and now if we check, we see that there's the old one, or there's the old one, there's the new one. They're not the same and they have different addresses, of course. Yeah, keep going. Okay. So let's repeat the exercise. Right. This is different. Okay? Oh, see, I already made a mistake. When I said it was a lie, it wasn't a lie. I'm about to tell you a lie. Sorry. Okay? So it did just what I said. Okay. Now, what you may have been told is this is just syntactic sugar. This is the same as s equals s plus hello, and that's almost true. But in a few here, we're going to actually see a corner case, an edge case, where it's not quite true. Well, soon. Okay? But you do an s plus equals there. Same behavior, right? Okay. Let's change the exercise. We'll change the string to a list. We'll change s to m. M is my favorite one-letter name for a list when I'm playing around. I don't use L because it looks too much like one. All right, so old m, 1, 2, 3. Let's see what they are. They're the same list. M equals m plus 4. As you would expect, right? I'm saying find me the object that refers to, which is this list. This list. Concatenate the list 4. You take a list 1, 2, 3 and a list 4 and use the plus on them. You get a new list. It's just 1, 2, 3, 4. And then take the name m, whatever m refers to in my local namespace, have it now refer to instead this new object I just created, which is the 1, 2, 3, 4 list that just got created. Okay? I didn't change old m, and so you can see these are actually two different lists. Okay? Let's repeat the exercise. Same. Here's the weirdness. Right? Why did this behave differently than string? Yes. So lists are mutable, strings are not. And so that is an indirect, so the fact that lists are mutable is why this is different. I would say, and I'm happy to be corrected, that that's an indirect reason why this behaves differently. And let me show you the direct reason. Okay? So why is going on? Well, code op is a module you can import. Dis is a disassembler module you can import. And I can actually say m equals list, m plus equals 4. Let's take that code, compile it with code op, and then decompile it with the disassembler module. And what does Python bytecode actually look like? All right, load name, call function, store name, load constant, in place add, what's that? In place add. There's the secret, okay? When you call plus equal, when Python sees the function plus equal, it goes and looks for an in place add operation defined on the object, i.e. on the class that the object is an instance of, or the type of the object, right? And if you do the same thing on S, so again, just change to use the other code, and the same thing, in place add. Okay, so what's really going on is we have list equals 1, 2, 3, there's the list, and here's what we're calling. Okay, is that we're calling the in place add, which implements the plus equal on an object. And I add for list, because lists are mutable, what it does is it takes the current, whatever m is. When you call this method with this parameter on the object that m refers to, the implementation of this function, or this method, sorry, changes the object to have a new, basically changes the list. So it's not 1, 2, 3, it's 1, 2, 3, 4 now. Okay? Whereas if you do str add, it does a copy instead of a change. Okay, and I could show you the same, you'd get the other answer. So, any experts? Did I get it right this time? Close? Anything you want to add to make it even more clear?
Maybe just that the IAD for lists returns
Right.
the same object it called it on.
Right, so and IAD returns the same list that what it got called on. Okay, so MIAD, the method IAD, when you call it, it has a return value, and that return value is the same list. Thanks. And I saw a question.
Is there a performance difference?
Between lists and strings?
Yeah, well, between like yes, essentially. Like between doing the IAD or just you can't end list together?
It depends on the data type, it depends on the implementation. I don't know those details, right? Like the list IAD method has some performance characteristics. It's going to be different than other data types characteristics. I think there's probably another question that you would want to ask, which I don't have time to go into, which is in particular cases, is there any advantage to using plus equal over equal whatever plus? And that, I don't know. Any quick answers out there, or the cases?
Any of these questions always about scale, like when it's a four-item list, who cares? You either have the same object return or you have a new object return. But if it was 10,000, a million people, you scale up, then the question becomes important. Right? So I think it's just a matter of like at this scale, the fact that you get two different objects and you use a plus sign, you don't use the plus equal, you can say you return the same one. Doesn't matter. Before it's probably not. At a different scale entirely, of course it doesn't matter.
Yep.
So you have to make a choice of what you want. You see the effect of your own decisions there.
Okay, so to summarize, make your code readable if at all possible, but in the rare cases when performance matters, well, yeah, then do your tests to see. Is that a quick summary of that?
Yeah, I'm just going to add, think about what's correct for the case, and then think about what performs well. Since they behave differently, only one of them might be correct.
Right.
Just sort of experiment and see which is better in the situation.
Or unit test. Okay.
Yep. So first think of what's correct for the case, then think about performance. Make sure you use the correct one in the two cases. Have your unit tests. Okay? Oops, wrong one. All right, so how are parameters passed? At times in the past, well, you may have heard the terms pass by value, pass by reference. I've had good advice, which I agree with, even though I used to sometimes use it, talk about it that way and say, which one is it in Python? I think it's less helpful than to just say, don't worry about that. We pass references. All right? Throw away the old baggage. We pass references. Don't worry, is it this or that, because it's, I don't know. And you have to unpack those and what they mean given your context. We always pass references, okay? So let's pass some references around. I define a function S, and I call it. I create a local name with that new string. I can see that it's hello. I call test1, and I will see, of course, that before it's hello, after it's hello there. And what's this going to give me? And why? Don't answer yet, not out loud, but think about, what's this going to give me, why? From what you know, we're passing a reference. Okay, well, let me answer it a different way. Right? So when you're thinking about passing str2, is it going to change or not? Oh, this is a hard question. Think about it this way. What if I just passed a literal? I'm passing the object. It's the same object I'm passing, actually, because of the way the string pool works in Python. For efficiency, it's the same object out there. Is it going to get changed? Are strings mutable? No. So it's not going to get changed. Okay? If I do the same thing with a list, what's going to happen? Are lists mutable? I've passed a list reference. I've called an operation, a method, on that object, which changes the object. The name that I left behind in the outer scope, the name that I left behind here refers to that same object. And so not only does it look like it changed inside, but when I look at it outside, it has changed as well. Okay? In both cases, I just passed the reference. But because the way strings and methods, to get back at my slight difference of how I would describe it based on yours, is that there are things like the methods on strings, the methods on lists, which are implemented differently because some strings are not mutable, they are immutable, and lists are mutable. Okay?
So is the parameter name S or M part of the function's local namespace? Is that how that works?
Is the parameter S or M part of the local namespace? Yes. It's one of the, so when you look at what are the names available in the function, there are parameters that, there are local names that get assigned, and there are the names that are implicitly assigned as part of the parameter passing. That's correct. Okay. So okay, everybody ready to get started again? So a couple things I learned over the break. So one is about performance of IAD, like in a for loop, should you use plus equal? And Alan mentioned to me, for background, in all my Python programming, I've had the luxury of not having to worry very much about performance. I've done timing on a few things here and there. I've thought about it, but I haven't been writing code that needs to be fast. A lot of people, most people, code speed matters because you're dealing with large volumes. So that's one of the areas where I'm not giving you very complete information. Alan pointed out that if you use a plus equal in a for loop, like on an int, it's linear. If you use something equals something plus the same something both times, it's quadratic. So definitely a performance advantage to using plus equal. Also got a comment from this gentleman who said that, at least in CPython, if you, like PEP8, which is the Python enhancement proposal that talks about what standard library code format and style should be like so that it's consistent and easy to read, says, try to avoid from A import B, but he pointed out that in his implementation, which is CPython 2.7 maybe, I'm not sure, that if you do a from A import B and use the B inside a for loop, it's a lot faster. I don't know if that's true across all implementations. I suspect it may not be. That might be an optimization that they could make in some cases in some of the Python implementations. And then there was a fascinating discussion about IAD that I'm not going to go into, I don't think, about another weird edge case. Sorry to tease you like that. So what we're going to do... It's okay. Did I do something? What's that? Okay, cool. So what we're going to do now is a short section on decorators, but don't think I'm going to teach you what decorators are or how to use them. I'm actually trying to teach you about namespaces, okay? And if you happen to learn something about decorators as we go, that's fine. It's a real short section, but it's kind of interesting. And the example that, it's a setup for the exercises, basically. So let's just go through it, then you'll see. And then I can give some credit where it's due if I remember. So let's define a function called square, which takes a parameter, which is a number, and we return the square. So square of 2 is going to be 4. Square of 3 is going to be 9. Now let's make a new function. Okay. Now if you're Functions are first-class objects in Python. You can pass them around, you can return them from functions, you can pass them as parameters to other functions, you can store them in data structures. Here's an example of a function, stringify. It's not a great name, but I think it maybe hints at what it's doing. It takes a function as a parameter, and the first thing it does in here is it defines a new function. And what this function is going to do is it's a function, convert to string, which takes a parameter n, and what it does is calls that local parameter kind of like thing on n, and then passes its return value off to the string function and returns it instead. And then the stringify function returns this function that I just defined when I executed the stringify function. Okay? If your brain hurts a little bit right now, that's fine. Like, you don't need to get this. A lot of people don't get this, and that's okay. There's plenty of Python programmers that don't think this functionally and about sort of functional programming and doing things with function, and you get by fine. Some people do and do some really interesting things that we get to benefit from. So if you're writing libraries and stuff, you might see this a little more often, for example. But there are plenty of good cases for this. So if you want another way to think about what this function would do, take out the str call, and just if you're struggling understanding what this does, just try either copying it down or rewriting it, whatever, without the str. Just get rid of this str paren and see what it does. And it's like an identity function. It just takes whatever you pass it. It just returns a function that does the same thing that the function you passed it does. Okay. Now what I'm going to do is take that same simple function. I'm just adding prints. All I did was add a couple print statements. Otherwise, it's identical to the first one that I gave you, the stringify. All right, so square is a function. If I call stringify and pass it this function, what I get back is, what am I going to get back? I'm going to get back this convert to string function with its definition. All right, and you notice that when I called it, after the function got defined here inside there, it told me it's calling it, and that's actually returning the thing. And it called it with the function square that I passed in. And if I now look at what square str is, it's this function convert to string at a particular address. And this is the case I said sometimes it makes sense to mess with a function's dunder name. Well, here, this might be a good place where you might actually want to mess with it. If you're doing something in a library or some other weird code that makes sense in that case, you might want to actually change convert to string to something more helpful. Especially if you're calling this function lots of different times. Like it's a function that returns functions, and if you don't, it's kind of an odd thing to have. You might call the function 10 times. You have these 10 different functions lying around. If they all have the same name, it's going to make your errors harder to read. That'd be an example of why you might want to change the dunder name attribute. So if we call square str of 3, instead of getting 9 back, I get 9. Okay. Decorators. One of the things decorators let you do in Python is you basically put this, again, this blank line doesn't need to be there, you put @, the name of the decorator, and then you put it right in front of the def statement, and it does, it calls stringify on it. It basically says, define this function, then pass it off to this, and whatever this returns, put it in the name cube. That's what a decorator does, a function decorator like this. Okay, and if I call cube2, I get 8, the string 8, not the int 8. Okay, so that was, again, like I said, a setup, and now here's a kind of weird exercise, and I give lots of credit to Glyph Lefkowitz, who had a great talk, Turtles All the Way Down, a couple years ago. Go watch it if you want to understand a lot of this stuff. Some of my stuff here was inspired by things he did, and this is one of the examples, sort of pulled from one of his examples. So figure out see if you can figure out what the exercise does. Anybody learn anything? So I'm pretty smart. I've got a master's in computer science. My weakest suit was always theory. And for me, metaclasses, functions, somehow that's just, and I found when I was preparing this that @value, this example is like, oh, that's easy. I can understand that. So some of you might have the same experience where if decorators have been hard for you, or just sort of thinking commonly, if you don't do it, it takes a while to get used to thinking about functions that return function stuff like this. This might actually help you. I don't know. I hope so. So let's just walk through it to see if you to explain what's going on for those of you that didn't get it maybe. So I'm saying, what's x? Well, it doesn't exist. So first I'm going to define a function called value. It takes a function as a parameter, calls that function, and returns the value that that function passed in as a parameter returned. Okay? It's not that different than a built-in call. So now I'm going to say def x return 1. So this thing is going to create a new function. And I was going to say called, which has the name x locally. I don't know actually if it gets the name x locally on its way to the decorator or not. I don't know how Python does that. The point is it creates a function which just returns 1. And then that code is passed off to value because we've got a decorator here. And in value, we call this function. That evaluates to 1. We return 1. So the return value of this whole thing is 1. So basically we're saying, give me a local name x, which has the value 1. Right? And again, this is Glyph Lefkowitz's talk, Turtles All the Way Down. Really, really great talk. Go watch it. And I think I pulled almost identically this out of his talk. And you can see that now x now exists in my local namespace, and it's just the value 1. It's not a function at all. Right? Its type is int. Now, is this a helpful way to use decorators? No. But my point is, function definition is a change to the namespace, and decorators just sort of let you get in the middle there. And what gets added to the namespace is the return of the call to the decorator past the function, which is what is in the def statement. Okay? And then all this is showing you as you went through it is without decorator, not using the decorator syntax. This is what happens. And again, whether or not, like here, x actually has one value in the namespace, then another one. I'm not sure if decorators actually go through that intermediate step or not. I don't know how decorators are implemented at that level. Okay. The class statement. Yes, please.
Do you need more useful examples of user decorators?
Nope. As I said, you might have missed it because you came in just as we were getting started. This is a little section about decorators. Its main purpose is not to teach you about decorators. It's just we're looking at how you can change namespaces, and it's kind of a diversion. Sorry. It would be great to have a section like that. I'm probably not the person who would want to teach it. I've written maybe one or two, and I don't use them very often. There are people who use them lots and have interesting things they're doing with them, and find them and tell them to do a tutorial. Sorry. Other questions? Okay. Class statement. So this next section, there might have been a few of you at the beginning of the first 10, 15 minutes, like, God, this guy is going so slow. Maybe this, you won't think I'm going slow if we get through this one. For some of you, this will be really hard to understand, but I hope most of you get it. And if you get it, I think it might, again, so like, oh, that's how it works. It's all so simple, which is part of the theme of that talk I keep mentioning, which is, yeah, it's all consistent and simple. That's one of the beauties of Python. Well, anyway, let's look at classes. So the class statement, and I'm going to give you the dry, what are classes? So remember what we said about objects, all right? And then I had a question for you. Many objects are instances of classes. The type of an object is its class. Classes are instances of metaclasses, right? And the type of a class is a metaclass. Simple question, are classes and metaclasses objects? Yes. Are elephants objects in Python? Yes. Everything in Python is an object, right? So it doesn't matter what you put in here. Are something an object in Python? The answer is yes. Okay. The class statement, here's what it does. When Python sees the class statement, very similar in many ways to the def statement. Python sees def, takes all the stuff that follows, assigns it to the name, which was right after the word def. Class is the same way. Class, a name, a bunch of stuff, all that gets evaluated a certain way, and it all gets assigned, wrong word, creates a new object, which is the class, And then the name, which was right after the word class, is what gets changed in the namespace where you define that class to refer to that whole object, which is the class that just got interpreted, just got compiled. Okay? And then the way you create an instance of a class is you call them, and you know this. Init is called automatically, passing the new object, which, by the way, was already created by new. So what I'm pointing out here is important. If you're coming from languages, I don't remember well enough, but so if you're coming from C++, Java, be aware, and I don't remember exactly what the rules are there, but in many languages, a constructor creates an object and initializes it. In Python, the dunder init method initializes an object. It doesn't actually create the object. By the time init is called, and you always use self as the first parameter name by convention, what's passed in is an instance of the class, and all you do in init is initialize it. If you actually have to mess with how it gets created, you can go mess with new. You can define dunder new in your class, and that will actually intercept the construction part, or the allocation of the creation of the object, as opposed to just the initialization. Okay? Now, when I access an attribute method name, like if there's a method defined on the class, and I try to get that method name off of a class instance, an object which is an instance of the class, it creates a method object, which binds the object as the first parameter. Blah, blah, blah. Very dry, dry, dry. But let me show you what it does, and hopefully this will become more clear. Okay, let's create a little class. I'm going to call it num. It's a subclass of object, which means it's a new style class. Anybody know when new style classes were introduced? I think it's been almost a decade. Yeah, it's a long time ago, and we're still calling them new style classes. So anyway, I just found that interesting when I was preparing for this talk. So it's an instance of object, so it's a new style class, which is all the ones you want to create nowadays. And it's got dunder init, which initializes it. And the way it's going to initialize it, it takes whatever object got created as part of calling this automatically, and then it's going to create a new attribute on the instance. That value is going to get assigned. It happens to have the same name. So the parameter's name is amount, and the attribute's name of the object is amount. And it's common to have that the same. And then I'm going to define one method, which is an add method. And whatever you pass in to the add method on the method called on the instance of the class, it's going to return whatever that object is plus whatever you passed in. Okay? All right, let's see it. Oh, by the way, yeah, I wanted to mention this comment character here. The reason it's there is because we're doing this, the interactive prompt. If you have blank spaces, it'll think I'm done. It gets to the next def and says, what? You indented for a function. Right? So that's why that's there. It's just because we're doing this in the read eval print loop. Okay. Num is a name in my, this got executed. So all this stuff, including the object, got compiled into something, some compiled object in Python, which is a class object, and the name num got added to my local namespace, and it refers to all that. So if I say, well, show me what it is, it tells me it's the class num, and the reason its name is num. So right, so num actually shows up two places. I used num here once. It shows up both in my local namespace and inside the class as the name of the class. Interesting. All right. This is talking about bound methods. This is not a bound method. This is an unbound method because I didn't access it on the instance of the object. I accessed it off the class itself. Okay? So it's very much like a function, but it's not. It's actually an unbound method. Okay? All right. Num.add similarly is an unbound method. What is let's look at the attributes of this class. Let's poke around and see what we can find out. Well, there's a bunch of stuff in there, and there's the add method. There's the dunder init method. There's the class, which we've seen in string a long time ago. It tells us, it's a class and it has bases, etc. We could go follow that rabbit trail. Format, get attribute. Nothing here that I want to tell you about yet. Okay? Let's create an instance of the class. All right, so remember, I'm slowing down here to make sure we get our mental model right, or at least close to what it should be. So Python sees the 2 and creates an integer object. It then calls the class. It goes and creates an instance of that class, passes the integer object off to the dunder init method of that class, which takes that 2 int object and stores it in this new object's amount attribute. And then that new instance of the class, the object instantiated from the class num, has a new name in my local namespace, which is num2. Right? That's what happened to get here. And I can access the amount attribute of the instance if I want. I can look, say, show me the best representation you can of this instance of the object. This is, it's a num object, right? So this num2 refers to an object which is at a particular place, and it's a num object. Why? Because its class, it's an instance of the class num. Oh, difference here. Do you notice when we said capital NUM dot dunder init, it said it was an unbound method, or an unbound class method, I can't remember which. Here, I'm accessing the same name, but as an attribute of the instance of the class, not of the class. And it's telling me it's a bound method, num init, the classes. So it's the class, the method's in the class, it's telling us, but it's bound, and it's bound method of this object, right? So this is how Python does, this is how self works, well, let's keep going, right? So num add, same thing, it's going to be a bound method of num add of the num object. Okay. Okay, so here I'm looking at the attributes of the instance of the class, not the attributes of the class. It has amounts. Whoa. Remember a long time ago I showed you help on dir, and I showed you that dir shows you some of the attributes of an object, or that can be reached via the object? Well, there's no add method or function or attribute hung off of num2, but because num is an instance of capital Num, the class, and it has an add method, it shows up in here, right? And that's why we could access it. Like so the dir, or the dictionary, and how it does it behind the scenes, I don't know all the details, but the point is it's making it look like there's an add function you can call, which is a specific kind of function called a method. And the difference between it and a regular function we're going to see is that it's already got one of the parameters wired up. Okay? Other than that, I think these lists are, I didn't check, but I think they may be identical in name, not in value. The values of these are different in some cases. So dunder dict on an instance of a class has all the attributes that were assigned. So the reason this is here, the reason this attribute, the dunder dict, has that is because in the dunder init method, we said self.amount equals 2. Well, self.amount equals amount. Okay? And here's where I just said they're not, like same attributes pretty much, but different values. Like num's got a dict too, but it's some other thing that I don't know much about. Okay. So what's this going to do? Let me slow down again. Python will see this, go create a new integer object, of type int, which has a value 3. It's going to pass that as a parameter to the add method. The add method, if you can keep looking at your page, it's scrolled off here, it's going to say return self.amount plus whatever you passed in. And so it's going to return 2. That's, by the way, I called it num2 because it's the number 2. Dot add 3, I'm going to get 5. Okay? I didn't have to pass the 2 in there, right? Now num add, remember, is the unbound method. And if I try to call an unbound method with a single parameter, unbound method add must be called with num instance as first argument. Got int instance instead. Okay, so that didn't work. That didn't work. Num.add 2, 3 doesn't work. Same reason, right? It's telling me something. I'm not listening. Unbound method add must be called with num instance as the first argument. Oh, I can do that. Let's call the num.add unbound method. Don't do this. It's not a good idea generally. Pass it num2, which is an instance of the class. Pass it the 3, which is a valid second argument. And it works. Okay? So here you see, this is using the unbound where you actually have to go figure out the class name and all that. This is stuff that, like this, and this part is usually stored in the object you're calling the method on. This part is stored in the object too and gets passed in automatically. Okay. This is what you should do, of course, right? Don't do this, do this. Unless you're in this tutorial and you're learning about how this stuff's wired up behind the scenes. All right. What if we create a new function? This is just a function. It has nothing to do with the num class. It has nothing to do with classes. I happen to use the word self as the first parameter name because I'm going somewhere. But you could use any name here, and this example would work just fine, right? And it's called set amounts double because I'm trying to do something. Well, if you look, looks very much like the dunder init method that we put inside the class definition. But here I'm doing it at the top level. I'm creating a new function at the top level. It's going to be called setAmountDouble. It's going to do the same thing as the dunder init, except it's going to, whatever passed in gets doubled and added to the attribute of whatever you got passed, right? So this looks a lot like the dunder init because I'm going somewhere. But the point is, this just is a function that you pass it something and you pass it something else. It takes the first something and accesses the amount attribute on that first thing. Let's hope it has one, or it will when we're done, if it can. And it's going to take this and double it and assign it. Oh, I used the word assign. You know what I mean. Okay? Numinit is an unbound method, numinit. If I do help on it, I could actually see it'll give you a little bit more about it, right? It says, one of the things it says is, it'll give me a doc string if there's one. There isn't because I kept it short. But it tells me, it even gives me the signature there with at least the parameter names. All right. I can do this. So what I'm doing is when I hit the class num had a def init, which looked a lot like a function, but because it was inside a class, it actually was a method. And what I've done here is I'm saying, okay, well, there is that init attribute of the num class, which refers to that function. I want to change it. Refer to this function instead. I want you to change whatever that class. I'm going to go on the fly, change the definition of num. Don't do this either, right? I'm going to... I'll stop saying that, but you get the idea. But let's do it. This is fun. All right. Unbound method, num.set. So it's an unbound method, just like dunder init was, right? It's not a function anymore. Well, is it a function anymore? I think the right answer is yes, it is the thing that was up here. It is a function. But when I access that function this way, it gets wrapped in something else, right? So it's not returning the function setAmountDouble. It's returning an unbound method. It's doing something to it. It's actually the attribute access on instances that does something funny behind the scenes, right? I didn't change the setAmountDouble function when I did this assignment, right? This thing still refers to some function out here in object land, and it hasn't changed. But when I access it through the num class, I get something different back. So there's something in between there that's doing some magic. All right. So if I do a help on it, I see here, setAmountDouble, self-amount, unbound, okay, unbound built-in num method. That's interesting. I didn't notice that before. Built-in.num. I don't think you would see that. I bet if you do that, you wouldn't see that. I think this might be related to the eval interactive console code I'm using to make this automatic. Okay. Num4 equals num2. So what just happened? There's a hint because I called it num4 instead of num2, right? Python created an integer, passed it off, created a new instance of num, passed the number 2, the int 2, off to its dunder init method, which is setAmountDouble. setAmountDouble took the parameter 2, multiplied it by 2 to get 4, set that to the instances, set the instance's amount attribute to be that number 4, and then that whole thing got returned, and I create a new name in my local namespace, which is num4. And it works, right? Okay, so I showed you what num init is. What's num2 init? It's a bound method. num.setAmountDouble of this particular object. Yes?
Could you have assigned the setAmountDouble function to an attribute that wasn't already defined in num?
Yep.
So you could have just created a new attribute and called it that?
Yep.
That would have been a bound method as well? Or would it?
Yeah, it should be. I've tried it, but I can't see why not. I believe so. Because it's when the attribute access happens on the instance, Python goes, there is no such instance. Let me check the class, because this is an instance of a class. And it goes to the class and says, there is one there. I'll take it, wrap it up, and return you something else, which is a bound method. Yes?
Is there any way to get back to that original limit or that cleaned up by garbage collection?
I believe it was cleaned up. I believe it may have been cleaned up by garbage collection. Again, we don't know it was cleaned up because garbage collection is a black box. We're not supposed to try to peer inside, but yep. Yes, so the original init would have been cleaned up. Very likely. I can't see why not. Okay. Sure.
When you said don't do this, why not?
Well, it's not easy to read. It's confusing for the user meaning the person reading your code. It's confusing for you when you go back and read the code. Are there valid reasons to do this kind of thing? Yeah, absolutely. But probably not this way. And I'll show you a little bit, I'll hint at that a little bit later, some valid reasons why you might want to do it. I mean, because there's plenty of good cases where you do want to create things on the fly. There are, factories, class factories, metaclasses, there's all sorts of rich potential for those. But that's not what I'm trying to do. I'm not trying to show you that here. I'm just trying to show you how things are wired together. Okay, so nice segue, by the way, 3 questions ago. Def multiply by. All right, this is a new function in my local namespace. It's called multiply by. It has 2 parameters. This one I didn't call self because I wanted to prove to you that you don't have to call it self. Of course you don't. It's just a function. Num value, return num amount times value. Straightforward, right? Takes whatever you passed in as the first parameter, pulls the amount attribute off of it, and multiplies it by whatever you passed in and returns it. Cool. All right. Now I'm going to do something not only that you shouldn't do, but I shouldn't do, but I'm going to do it anyway. Let's make a mistake. What happens if we take this? What happens if we do this? Remember I said it looks for it in the instance, can't find it, goes to the class. Well, it's going to find it now. So num4.mul equals multiply by. It's just a function, right? It's not a bound method, it's not an unbound method, it's just a function because I just add a new attribute to an object and there's no, you're allowed to do that unless you've used dunder slots to tell it not to, which I'm not going to cover today. You can go look it up. And there are other reasons for slots. I've not used them much, so don't quote me on. That's why I'm not going there. Okay, so now if we call num4 mul5, what's going to happen? Why? What kind of error? I don't have enough parameters, right? Takes 2 parameters, I'm passing it 1. I'm just calling a function, right? The fact that I happen to have stuffed it as an attribute of an instance of num, well, Python doesn't care about any of that, right? So it says it takes 2 arguments, I only gave it 1. Oh, let's give it 2. Why did that work? It's just a function that takes 2 arguments, and I gave it arguments of the right type. Well, and what does that mean? Well, duck typing, right? I gave it an argument where it would work, where it's the right number of arguments. The first one has an amount attribute, so it won't give me an attribute error when it tries to access it, and it'll return the number. Okay, let's make num5 a different number. Oops, I bet that should have been a num10. Let me make a note of that. So, should have been. I mean, it'll work. It's just the name might be a little less obvious. Okay, so num4 has a mul, num5 doesn't. Why? Because I assigned it to an instance of the class, right? So that makes sense. Num4, here's the instance. It has a mul that I just added recently. Not here, but further up. It has the add. Well, it doesn't have the add, but it's in the class. It has amount, which is the attribute stored in its dunder dict. Num has an add, doesn't have a mul. So that's why it's not doing what we expect. Okay. So let's fix the problem. Put it where it belongs. If I want to do this kind of hacking around, then let's put multiply by, which we intend to be a method of the class num, up in the class, so that when we access attributes locally, it'll get the right, it'll find it. The way it gets to it will change the behavior, and what will get returned isn't just a function, it will be a bound method. All right. So now this will work, right? God, why didn't this work?
So then it's local.
Yeah, I didn't get rid of num4's real. Again, you can't tell from this. That's a bit confusing. But the point is num4 exists and it's a multiply. So now I've got an instance of a class which has a mul attribute, and the class has a mul attribute, and I say, well, give me this one's mul, and it goes, oh, okay, it's a function, here you go. If I get rid of it, and then I call nummul, you see it's up there, it's not here, but it is accessible from here, and it shows up as a bound method on the class of the actual object. Okay, so now num4.mul5 should give me 20. Phew. Is this fun? That's cool. I hope you're enjoying it as much as I am. Okay, a little bit more. How does it actually do this? Well, we can actually get at some of it, and I'll show you what that is. There's the num4 object. What this does is it looks for mul in the instance, can't find it, goes to the class, finds it there, returns something other than the function that's up there. It returns a bound method. All right. I am class, I am func, I am self. Two of those three pairs are identical pairs, I believe. That two of the three, they actually are. Like I don't know of any cases where they wouldn't be the same. The third is different, very different on purpose. So let's look at num4 mul I am class. So when we access this attribute on that object, it's going to go look in the class and return me the function wrapped somehow to be a bound method. That bound method has this I am class attribute, which is the class num. Right? And it has a dunder self method, attribute. So num4, not only does num4 know what kind of object it is by looking at its dunder class attribute, but if you access the bound method mul off of the num4 instance, which it gets from the num class, that bound method has an I am class, which refers to that. So it's got these couple ways to get it. The we can't get at that, right? And the reason it needs this is because, well, sometimes you might just take the mul method and pass it around after it's been bound. And this thing, num4's mul bound method's self attribute is num4 itself. So that's the binding is right there. And like I said, dunder self and I am self are the same. Num4 mul.func. Interesting. It's not saying a bound method anymore, is it? Why? Well, because I'm saying this is the method I'm trying to find. That method has a dunder func, and that dunder func is actually a function. Remember I said a bound method is something that sort of wraps the func? Well, here it's keeping a copy behind the scenes. And dunder func and I am func are the same. And I don't know of any cases where they wouldn't be. Happy for corrections from any experts in the room. If I do a help on it, well, that's the help from that function. So the reason I am class and dunder class are different is because dunder class on num4.mul, which is a bound method, is the class of that bound method, which is an instance method. Whereas num4.mul.iamfunc is the actual, I am class is the class that it's a bound method of. So we need two names there because there's two very different things going on. Okay, what's this going to do? Anybody tired of this yet? Confused? What's num4 mul5 going to do? Oh, it's just going to work. We get 20. What's this going to do? Get it? That's what it does. Something sort of like that. That's the syntactic sugar of object-oriented programming in Python, is when you call num4.mul5, it goes and looks in here, gets a bound method, goes and finds its function, passes as the first argument to that function, it goes and looks back at num4, the object that we just called, oh, let's go find the instance, which is num4, and then pass the 5, which we passed it, and call the whole thing, and we get the 20, right? So that's the wiring behind the scenes that makes Python instances and of classes and classes work. Okay? Little exercise, at the bottom of page 15 for you to try the same thing. So this will take you a while, maybe 10 minutes. Have fun. Okay, let's move on. So I'm not going to solve this one for you. The solution is fairly straightforward if you look at the previous section. Again, if you didn't catch this example and this section, don't worry about it. There's still doesn't make you a bad Python programmer. Might make you a better one. But for some of you, I think it will help you understand what's going on behind the scenes, and some things will be less confusing, is my hope. Let's look at the type function for classes. So this same talk I keep referring to because some of this stuff, like some of this material I developed earlier, but this is a great talk. In this talk he says, the class statement is just a way to call a function, take the result, and put it into a namespace. Okay? And it so happens that you've seen the type function, you call type and you pass it an object and tells you what the object's type is. Well, you can call type a different way. One of the other signatures the other signature for it is you pass it 3 parameters. And the first one's not an object, it's actually a string. And the second one is some bases, and the next one's a dict. Well, let's see what that looks like. Clean up that background. Okay, so here are the 2 ways you can call type. Name, double num. So double num, double num. Earlier I showed you that we declared num once and it showed up in 2 places. Well, if I want to do it manually behind the scenes using the type function, I have to do it both places myself. Okay? The bases is a tuple or a list, a sequence, iterable probably, of all the base classes you want this to have. And so here it's as though I said class double num, open paren, object, close paren. Init, so the next thing is a dictionary, and that's a dictionary of all the attributes that should be stuffed into this new class object. All right, so I'm going to stuff 2 in. I'm going to say, make one of those attributes this thing, and pass it in this function I previously defined. And the other one, I want you to call it mul, and pass in that other previous function I defined in the last section. All right. So now num6 equal double num3. Its type is class double num, this new object that got created. Well, again, the new object that type created for us. We can look at its class. It's got a dict, which is amount, because the init method, which is the set amount double, took the 3 and doubled it and stuck it into the amount attribute. Again, if this is confusing, you might have to go back and look at those things we previously defined. You can access the amount, we can call it, you get 24, right? So all that kind of stuff works. All right, so this is A dynamic call to type is what the class statement actually triggers. Now again, there may be a backdoor to it that Python uses, I'm not sure, for efficiency reasons, but conceptually, this is how it works. However, when the class definition is read, if dunder metaclass is defined, then the callable assigned to it, in other words, whatever you assign to metaclass will be treated like a function, i.e. it will be called, instead of calling type. That's how metaclass wiring works, right? This rule right here basically says, implement it yourself if you want. Do whatever you want. And again, if you want to do it the hard way, the hardest way, then you just go recreate whatever type does. There are other ways. We're not going to talk about metaclasses lots except about this much to show you. That's what a metaclass is really. And now that you understand what the type function does relative to how we messed with it behind the scenes ourselves, now you can see that all you have to do to make a metaclass is just make it any callable accepting arguments, name, basis, and class. And there's some easy ways to do that that are recommended if you go read about metaclasses. Upon class creation, the callable is used instead of the built-in type, and that's straight from the language reference. Okay? So if you've ever wondered, whoa, metaclasses, what are those? This might give you an inroad into, oh, okay, it's just a different way to control how a class gets created.
Sorry, where, in which namespace do you define under metaclass?
You're about to find out. I'll show you. Okay? And I'll show you actually by letting you read it and try it again. And this is, again, what I just told you, little hint at what metaclasses are. It might make more sense now. And a setup for this exercise, which is not one of those weird ones. And, by the way, if you're running Python 3, like choose one of, where the little says or, choose one of Python 2 or Python 3, because the syntax is different of how you answer that question. Where does the metaclass get set? Okay, let's look at briefly what this is doing. And again, this might feel kind of funny because really what I'm showing you here is, this is how, this is another way, a class is another way to change a namespace. And with this new understanding of what metaclasses do and how they work, well, so all I've done here is defined a simple function called one, which looks like, meaning it takes 3 parameters, just like the type function does when it's called in its mode of creating a new class. All right? And then in Python 2.7 and before, not sure how far back, oh, look at that, I forgot to put the object in there. I wonder if that matters. I mean, it doesn't matter for the example, but I meant to make that a subclass. This is an old style class. I meant to make it a new style class. And again, I'm not an expert on metaclasses. I've done a class factory once, but it's kind of interesting. I've poked around at it enough that it helps me understand what's going on. And if you're in Python 3, then you can actually pass a parameter like this, and I'm not running Python 3, so I get an error. Okay, and there's the pass for that same thing. Okay, so now x equals 1. I forgot to reset my interpreter. It's all right. Def1 class. Should have reviewed this one last night. I'm confused. Sorry about that. What's that? Right, so why did I, is there a typo in here? Oh, yeah, no, it does. Here's what's going on. Yep, I remember now. Right, so class X, what that does is it just calls a function and takes the return of that function and puts it into the local namespace, right? And so what happened here, sorry, it's already passed. Let me back up so we can see it better. Okay, so here's the setup. Here's the function it's going to call, which looks all like type. This says when you create when you create this class, instead of calling the type built-in function with all the things that usually get defined in here, like attributes and the name and stuff like that, instead just call the one function. And the one function is going to take a name and bases and attributes, right? And so we're going to call that function instead. We call that function, and this part you have to ignore if you're running Python 2.7. When we call this function, we're basically going to, all the class does is calls a function and creates a new entry in the local namespace. So we're going to get an X in our local namespace. As soon as you see class and then an identifier, you're going to get that identifier inserted into your local namespace. In this case, its value is going to be whatever our super fancy type function does, which is not super fancy at all. It's super simple, and it just always returns an integer. It always returns the int 1. Okay, so this is just a fancy way of saying x equals 1, right? And I'm not going to go through this in detail, but you can do, similarly, you can do class decorators like that and put it in there that way. Again, don't do this as kind of a weird example that sort of helps you cement, hopefully, you know, what's type doing, what's a metaclass, how's it work, how's that wiring work, and then we're misusing it by wiring it to something that's so simple that we're just getting a class object, which is an int, which is not very, is nothing you would ever do. What we're going to do now is I'm going to show you a little bit about standard class methods. So I've mentioned that there's all these dunder methods that are in classes, or can be in classes, and I'm just going to review them briefly. I'm not going to give you lots of details on them. I've mentioned these. That one gets called when an object gets, an instance gets cleaned up. Repr and str you probably know about. I'm not going to talk about format. These ones, Getattr, Getattribute, Setattr. Getattr is, if you define it, then when you try to look up an attribute on an instance and it fails, Python will first say, oh, is there a Getattr method? If there is, it'll call that instead of just returning you an attribute error. And there's some interesting things you can do with that. Getattribute is even more aggressive in that it is called if it exists on a class, then instances of it, every time you access an attribute of an instance, it will call that function instead of using the normal attribute lookup. And that's tricky to get right because you can't use regular attribute lookup inside it or it'll get an infinite loop very quickly. Setattr, similarly to getAttribute, it's when you set an attribute, when you delete an attribute. Call is kind of fun. Anything, if it's a class and you want to make it instances callable, like you just define the call method and it'll get called. So sort of a different way to make something that, again, I'm not going to say is a function or is a class because it's just callable. In Python, the notion of what's callable, well, you can call a class to create it. You can call a function to have it execute some code. You can call the instance of a class if it has a call method, and it'll do whatever you tell it to do. Okay. Len, getatom, missing, setatom. These are things that implement things like how you access an element in a list, an element in a dictionary, if there's one there or not, the in operator, not in, etc. And then there's all these math, lots of math. Mostly math. Any of these not math? I think I got those, they're all math in there, various kinds of math. And some conversion kinds of things. And then the R's, which are, if you have two objects and you've defined an dunder add on this one, and you say A plus B, it'll call it. But if it can't find it, it'll go look at the other one to see if it's got an R add instead. And then enter, exit, next are context managers and iterators. So, on the bottom of page 17, you have a bonus, which is an exercise you can go through later after the tutorial, because I've only got 25 minutes, and I want to, and I did this on purpose. I put in enough material that we wouldn't run out, thinking I might need to cut this, and I am cutting it. So an interesting, trivial little example of how you use Getattr, not a very realistic one, but I actually have used Getattr a couple times, and very useful when you need it. On the next page at the top, there's an exercise you can do. Page 18 at the bottom, a little bit about properties, which I'm not going to cover, and we're going to skip straight to iterators. And I think we can get through, for sure, iterators and probably generators too, and maybe that last example. Okay? So, how do iterators work in Python? Well, here's the scoop. Here's the skinny. When you have a for loop, for something in something, the thing on the right side of the end gets, whatever it is, it gets evaluated. It might be a function, gets called, it might be some complicated expression, whatever. But the point is that thing gets evaluated, and it's going to be the iterable. And then Python calls the iter built-in function on that to get an iterator, okay? It takes that object and calls next on it over and over again. And eventually that thing, the next method on it, I said function, doesn't matter, point is it calls it, is eventually it should raise a stop iteration, and when it does, the for loop catches the stop iteration and says, oh, okay, I'll exit. So you never see that exception. It's an example. Exceptions, people think exceptions are for errors. Well, that's the common case of a more general statement, which is our exceptions are kind of a nice way to send what I would call out-of-band data, to use an old radio term or transmission term. It's when you need to get some other information back instead of the usual stream. So what does the iter function called on foo do? What it does is it first checks to see if there's a dunder iter. If it is, it calls that thing. Otherwise, it has a fallback, which is it tries to call get item. So if something doesn't have a dunder iter, but it does have a get item, iteration still works. Okay? And get item, of course, might write an index. It starts at 0, calls, get item 1, get item 0, 1, 2, 3, 4. Eventually it runs out, raises an index error. Iter turns that into a stop iteration. For turns that into a signal. If it says, oh, stop iteration, I'm supposed to stop. Okay? That's later. So let's look at this and see if you can, let me show you what I mean by that. We'll start with the fallback position of get item. And what I'm going to do is define something that looks a lot like a list, because I want it to be something that doesn't have a dunder iter method on it. And this class that I'm doing myself does not have a dunder iter method on it. It's got an init, it's got a get item. The init just takes whatever you pass it and saves it in self.items. And the get item just tells you got called and then tries to access the element. So it's just passing it off to the actual get item implementing whatever you passed in. So let's pass a list. All right. So I can do that, and it works. So it's acting a lot like a list would. And it raises an index error when I try to get one that's past the list. Of course, I can access it the normal way you use, the normal syntax you use, which is square brackets to call those things, and same behavior. It doesn't have a dunder iter, told you, but it does have a get item. Okay, if that's true, then if I call the iter method, the iter function, it will go check and figure out, oh, it's got a get item. I will use that thing, and here's how I will use it. Right? I call the iterators, which is something that got returned by this function. I'll call that object's next method, and it will turn around and call get item because it figured out that thing doesn't have a dunder iter, but it's got a dunder get item, and it calls it, and it calls it, and it just keeps calling it. And what's going to happen now? Stop iteration. IT, the object that IT is, it caught an index error, and it turned it into a stop iteration exception and returned that to our code. All right? Now, if you call list of m, you take this object, which is my fake list, and you pass it off to the list function. List function just takes something and goes through a for loop and fills it up. It just works, right? You didn't even see the stop iteration here because it got swallowed by the for loop that's inside the list function, presumably. I don't know, I haven't looked at it. There's the for loop, right? For item in M, print the item. So all that stuff got transferred. So you don't see the index error, you don't see the stop iteration. That's all part of the iterator protocol. That's how it makes it work. Slight digression here. By the way, we assumed you pass a list. We could pass it something else. And that works, but that doesn't. Right? So you can do that. This is an example that works for a very narrow way to do it. You can exercise left for the reader, go figure out why that didn't work. It's fairly straightforward. But yeah, we can do, and then if we try a list of m, sorry, I was going to say why this doesn't work as well. Okay. let's play with iterators a little bit more. Let's rig a regular list, M, not my fancy, simple little class, but let's just do that. If we call reversed, you may have seen this before, you can do say like I for I in reversed M. Well, it returns something which is a list reverse iterator object. All right, let's save that thing. Let's make another one and save it. Give it the name IT. Its type, okay. It's got a next. Yes? Happens to have a dunder iter too. Iterators have dunder iters. And I can call it. Right? And it's a reversed iterator, so it gave me the 3, the 2, the 1, and then a stop iteration. And it has to, by the way, when you define your own iterator, you have to make sure you, the definition of next is not just that it calls, not just that it raises stop iteration when it runs out, but that it keeps raising stop iteration after it has run out. If you get that wrong, you'll get some weird bugs if you're defining your own iterators. And again, it's when you need them, they're great to have. I've done a couple. It just keeps raising it. Look at that. Okay. And again, this is the way we'd usually call it, for I and M or for I and reversed M or something like that. So M is a list, 1, 2, 3. It doesn't have a next method. Remember, it used getItem instead. it.next, 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 stop iteration. Okay. And these work, of course. That's how they actually get done. And so again, we're just reinforcing. Same thing. GetItem is getting called conceptually behind the scenes. And this actually is a little bit misleading because the reason I did the class is because it turns out that list has a built-in iter method for performance reasons, I assume. Okay, what's going on here? IT equals reversed M. Let's make IT2 IT dunder iter. IT2 also has a next method. By the way, the next method turns into dunder next in Python 3. The name changed. All right, so M equals list iteration, list comprehensions. You've probably seen these. Just a list. Generator expressions. You've probably seen these. Same syntax. Change the square brackets to round brackets or parentheses. And it'll be a list, right? No, it's not a list. It's a thing. It's a generator object which has a type, and it has a next, and it has a bunch of other things, including GI running, GI frame, GI code, send and throw. Interesting things related to generators and generator expressions that we're not going to talk about. And lots of stuff there as well. Okay, I think close to done this, right? I never had that. Oh, yep. Okay, your turn to go play with iterators a little bit to help you understand how they work. And I'll give you about 3 or 4 minutes for this. That should be enough time. Okay, I'm going to move us along now. I know that most of you did not finish this section. Some of you are actively engaged with TAs getting questions answered, and I'll give you a chance in 12 minutes to get those answered. But we're going to see if we can cover 2 more sections without rushing too much. So skip page 22, another bonus for you to do at home. And let's look at generators, which is page 23 near the top. Okay, so generators, you saw an example of a generator expression, and we saw that it has this next method. Notice here what's going on. Okay, generators can be exhausted. People can be exhausted. They can be exhausted, meaning when we have this generator, we consume it with list, and then we try to consume it again, well, it's all gone, and that's a normal thing. And here's how you would typically see a generator expression used. There has been a wonderful might be too strong a word, a very nice movement in Python towards more and more cases where we do lazy evaluation, and that supports lots of things like big data and data that, stuff that, like when do you get to the end of it? An example would be let's receive transmissions from a network. Well, when are you going to get to the end of it? You might never. Maybe it's open for years. Who knows? Maybe not years. But the point is, you don't know where the end of it is. And so we can, by doing lazy evaluation, we only, we handle one piece of data at a time, but we get to code it as though it's all there, almost, which is easier, makes it easy for us to think about. The usual way that you write, so generator expressions is one way to make a generator. The other way to make a generator is by defining a function, and somewhere in the function, put in a yield statement instead of a return statement. And you've probably seen this, and here's a very simple one, right? So what is that thing? What is list 1, 2, 3? Nope. A lot of people get confused by this. I have occasionally, right, I forgot. So it is sort of a generator, but it's just a function. If I call it, it returns a generator. And again, to say it's not a generator, to say that this is not a generator is also misleading. It's kind of this weird semantics. But the point is you call the thing and you get the generator object. And then you can call on that. Okay? Again, it's not identical syntax in some cases. In many cases, it looks exactly the same. And it raises a stop iteration. Okay? Here's an example of a slightly more realistic one, right? We're going to try and range 0, limit 2. Well, let's call this thing, right? So we say create me one, even numbers up to 3, call next, call next, call next, done loop falling out. So it just does all that machinery of the iterator protocol for you. As soon as it sees the yield in the function, it turns it into a generator, or a generator function actually. It turns it into a generator function, I think is the right name for it. And here's how you would call it for I and even 3, right? So if even's a function that returns a list of even numbers less than 3, or if it's a generator function that will return them one at a time, the way we call it's the same. And it gets called when we call loops as well. All right. Which one's easier to read? Right? So generators, we think about, they're great for making things more performant. Not, you can handle lots of data. Well, it's also just the mentally, that's, in my mind, a lot easier to read than this one, where I have a result, and I result append and return result. And yet, when you call it, they're the same, right? So there's a nice, tidy example of how generators just make for cleaner code, as well as more efficient code when you're dealing with stuff that's big. You're not using much memory. Okay? A quick example of a more useful kind of generator function that I have written things like this occasionally, right? I've got a bunch of paragraphs in a file, and I could do for line in, open the file, and I get every line out of the file. But what if I want paragraphs? Well, just create a little function like this that does what you want. And then I open the file, and there I go. This is some tab. There's 1, there's 2, there's 3. It gives me the paragraphs, all 3 of them, instead of giving me the lines. And I've hidden the complexity of that. Because sometimes, you're reading a file, you're turning into paragraphs, you're trying to collect it, and you can get really awful code. Generators let you peel that stuff off and make it nice and clean. Great talk on generators that David Beasley gave a few years back. Some of you are nodding, you've probably seen it. Interesting stuff where he did some performance analysis of some simple, sort of mimicking pipeline in the Unix paradigm, command shell paradigm, but using generators instead. A good talk. So what I'm going to do at this point is not let you do your exercise on generators yet, because I'm going to guess that you would rather me show you one more section and explain it, and you can do that later. So I'm going to show you just a couple examples, one really, that matters. I'm going to show you 2 examples. I've mentioned this before, that functions are first-class objects. And other things in Python are first-class objects. And some of you will have seen sort of things like this, but once you get this in Python, you'll start to use it. You may start to use it more in some cases. In some cases, you might start to use that fact too much and make for really unreadable code. And so don't go down that too far, but sometimes, I've seen, I've looked at code in Java, it's just page after page after page of typing, monkey typing in Java. I'm like, you could do that with 10 lines of Python. Let me show you a couple of examples. Let me show you one simple example. What's my slide here? Oh, slices, functions, classes, etc. Same as what's in your handouts. You've already seen it really if you're looking at the handout at all. Okay, so let me show you a quick little example just to demonstrate this. I can add 7 plus 3. Woo, that's exciting. Operator is a module that has a bunch of built-in names which actually are the same thing as those operators. Okay, so if I call operator.add 7.3, it does the same thing. So I'm going to build a little calculator with this. Let's make a calculator. And it's real simple, only handles single digits. And I'll do it by sort of iteratively developing the code in the interpreter, in the eval print loop. So if I take this thing and just split it, in a sense, I can do a list is a sequence, a string, sorry, is a sequence, and so I can do tuple assignment and it just works, right? And suddenly I get the 7, the plus, and the 3. I could turn the 7 and the 3 into ints by calling int on them. And then I can turn them around so I get plus 7, 3 instead of 7 plus 3. And then I'll just call plus, I'll call add, 7 I'll call left-hand side, 3 I'll call the right-hand side. And I get 10. Okay, well now let's create a little function. But first we need a data structure. So I'm going to say I want to map, when you see a plus, I want you to call that. When you see a minus, I want you to call that. And now I write my function. And then I can use that data structure the same way, right? So instead of plus 7, 3, I'm going to say ops op 7 and 3. So ops plus goes to add left-hand side, right-hand. It's going to be the same as this up here. It's going to be the add 7 and 3, and I get 10. So now I'll create a little function. Calc the expression, just take all these pieces I had and throw them into a function. And I can do calc 7 plus 3, calc 9 minus 5. Cool, right? And this will scope creep, right? And how do you fix scope creep if you've done it this way? Like that. I'm done. Right? Again, kind of made up example, but the point is there are cases like, and I'll show you the next one I'm going to show you is based on a real example where I've used this kind of thing, which just is, it's great. So as soon as you add operator, ops slash equals operator div, it's done. An interesting question is this ops dict, is it code or is it data, right? Like in other languages you're coming from, there's a clear, well, there's the data and there's the code. Well, here we're kind of mixing it a little bit more than you do in a typical language, than you typically do in a typical language. Most other languages have ways you can do this, but they're much more painful. Okay, let me show you another example. Oh, and I think, look at that, I lost, because of my adjustments to make this big for everybody, I lost the very top of it. So take a look at the top of page 26, and you'll see that what you missed was class unpacker. So here's the definition of the class unpacker. It has a dictionary called slices, which has 3 names and 3 slices. Did I skip the section where I actually showed you slices, or you tried slices? I think I did. You may be a slice. A slice is how attribute access works, and you can actually just create them as first-class objects in Python. You may have seen this, you may not have. I'm going to pass it a record. Think line of text. For the example this came out of is flat files, like fixed length, this field, these characters are all interpreted always the same length. Sort of old mainframe style and other style format. And think a standard that's used by lots of companies, including mine, to communicate data back and forth between them, which uses this old style format and has 50, well, probably 30 different formats. And the formats are defined in tables that look a lot like this. And I want to write a library, which I did, that can just read any of them. And I didn't want to write 1,000 lines of code. I wanted to write 100 lines of code and make it maintainable and extensible easily. So I did something similar to this. I've simplified it to make it work here, but it's more like 2 pages instead of this much. So when you create one of these new things, it just stores it away. And then when you try to, if you call an attribute on it like header, trailer, or middle, it's not going to find it because that's not one of the attributes of the instance. So it's going to call Getattr, and it's going to go look it up and do the right thing. Right? So what it's going to do is if you call header on an instance of this class, Getattr will be called because Python will look up header and it won't find it. But instead of raising an attribute error, it'll say, oh, you've defined a Getattr method. I'll call that instead. See if you can handle it. It'll look for a header in self.slice and say, yeah, it's in there. It'll then grab this slice, 03, pass it off to the getItem method of whatever it was that I scrolled away, probably a line of text, like a string. And it's as though I said, give me 0:3 with square brackets around it, right? And of course, if they call header 2, which doesn't exist, well, I'd still like to give them an example. I'd give the user an error. That one really doesn't exist. Okay, let's use it. Look at that. Cool. Again, for me, the impact of this is, remember, 20 or 30 formats, 30 to 50 attributes on these huge long lines, and we need to write code that read these things and did a little bit of transformation stuff. And so now we have a library that what you do is you create a new dictionary, and there's even some functions where we take the file format definitions and just slurp them in, and we've got the format. We can access it in a readable way. Okay. We're about a minute over, so we'll just get to lunch barely as they're starting. I didn't talk much about partial functions and closures, except I did demonstrate one earlier, just didn't call it that. A little exercise on name tuples and operators and those pieces on iterators. I encourage you to go do those sometime. I hope that you had some aha moments and that this will serve you well. Thanks very much for coming.